The other thing, be sure and remember, people, that they have been grossly misled, if not lied to, about Benghazi, keep your doctor, keep your insurance, IRS, all of that kind of stuff, because it'll make them think maybe we're being misled on the climate change issue. So just keep repeating that the true environmentalist out there, which is 80% of the population considers themselves an environmentalist, that you need to go and talk to those people and tell them that the true environmentalists have been misled on this issue. And you can get their attention. Now, the three good folks up here, Tom Wysmuller, he gives an annual regional weather forecast each November in New York City, on New York City radio, and Tom has a stunning track record that includes a couple of years ago, no snow, and then he also forecast the brutal snow and heavy snows with warm spikes in between of this past winter, and he did all of that before those things happened. So way to go, Tom. Dr. Hal here, he's the right climate stuff leader, and he is a real rocket scientist. I say genius, and he blushes. But he's been instrumental in solving all of those early rockets that blew up because they had such vibration problems. And not only did he do that, he laid out the software for how these pilots had to land those capsules on the moon so they wouldn't flip over. So you're going to hear a good story from him. We've got Colonel Cunningham sitting down here on the left. Walt and I go back a few years ago, having triggered a letter to NASA admonishing NASA for making unsubstantiated claims, alarmist claims about global warming. It got international attention, but then it faded pretty fast because it didn't have any impact on our commander-in-chief. He ignored it. And anyway, that's that. In addition to his bio that you have in the thing there, Walt has degrees in physics and geophysics, so he's more than just an ordinary astronaut. He's also a physicist, and he was founder of Earth Awareness Foundation and was also on the advisory board of the National Renewable Energy Lab for 5 minutes. Tom, go get him.
Thank you very much, Leighton. Let's see if I can get these slides to work. Not quite. You all had this card in your packet, so my contact information is on there. So I'm not going to spend any more time on it. We have a world here. It's your world, but it's kind of been taken away by Al Gore and the IPCC. Now, how did they take it away? Well, they told you sea level was going to rise. In fact, this is the specter that you're getting. This is Heidi Cullum's book, Weather of the Future. This will never happen. Not in anybody's lifetime in this room or anybody anywhere else. But it does sell books. And that's one of the problems. We're being sold a bill of goods. This is let me go back into the past. About 130,000 years ago, 120,000 years ago, we had sea levels approaching what we have today, right up here. Then the giant glaciers formed when they started melting 18,000 years ago. Sea levels rose again, and now they've kind of flattened out. The IPCC is predicting something else. They're saying that by the end of this century, we're going to have 1 additional meter of sea level rise in their highest, what they call them representative concentration pathways. And they're related to CO2. More emissions, the greater the pathway. 1 meter is almost, it's about 40 inches. That's an awful lot of sea level rise in a century. Now, not to be outdone, U.S. Army Corps of Engineers decides, well, we're going to go for 2 meters, 1.8 really, and they had 3 different pathways. Scenario 1, 2, and 3, and well, this is the Army Corps of Engineers. Let's see, this is not working. There we go. Let me go back one more. Did I get the right one here? Yeah. This is now the National Climate Assessment that was just published a few weeks ago. Now they're saying 6.5 feet. Their lowest is 20 centimeters down here, and that is still double the rate that we've had sea level rise in the last 170 years. They're never going to see the top one either. This is Jim Hansen. Now Jim Hansen, by the way, if we go back, in 1988, he was asked by a reporter, how do you see things in 40 years? And he says, well, you see the highway down there, the West Side Highway outside of his office? It's not going to be there anymore. Based on a doubling of CO2 from pre-industrial times. Well, right now we've gone 25 years into that 40 years. We've had 1 inch of sea level rise. There are 10 feet to go for him to make his prediction, and it's got to happen within the next 15 years. You take a look at the, let's see. This is Jim Hansen's slide where he decided, realizing that sea level was not rising, he said it's really going to be exponential. So by the mid-century, it really isn't going to rise at all. He won't even be alive here, neither will I. And yet we're going to get 4 meters of rise. And this is meters, not feet, in the last 20 years of the century. Don't hold your breath on this one either. This is La Jolla. Now you heard about La Jolla this morning. Scripps Howard is there. I go back here, let's start it again. This is in 1872, the same piece of land. The sea level hasn't risen. I'll go through this one more time. Same beach, same place. So there is sea level rise, but not much. So what's really causing it? Well, we have 3 different sources of sea level rise that we can measure, 3 different metrics. We have tide gauges, we have American satellite and French satellite, and we have NVSat, which is the latest European satellite. The thing that is, first of all, you notice the metrics are all different. Tide gauges average about 1.7 millimeters a year. Topex Poseidon 3.1. NVSat is all over the place. But the characteristic they all have in common is they're all linear. They're all measuring a linear trend. And are they perfect? No. Let's see if I can. This is what a tide gauge looked like. This one happens to be up in New Hampshire. They're all over the world. Some have been around for a long time. Now, parts of the world have sea levels subsiding and raising. Why? Because the land next to it is subsiding or increasing. Some of them are more reliable. They've been around. There is a bias to them. Why is there a bias? Well, people tend to put tide gauges in where the sea level is, quote, rising or their land is dropping. So the coast of Norway doesn't have too many, but Holland has a lot because they're worried about it. So there is a bias in even the tide gauges, and they are direct measurement, and they are still linear. This is what the permanent sea level site from the British looks like. You click on your city, and you get a map that looks like that. And this happens to be New York City. It's linear. However, sea level is rising. Why? They put their tide gauge on a battery in New York City. The battery is landfill, and they're putting buildings on that landfill. Well, they're going down. Near New York City, New Rochelle, Port Jeff, sea level is fairly static. This is a subset of that time period. Boston's the same, by the way. After 1960, Boston sea level goes up because Boston is sinking. They put up 19 skyscrapers in 20 years. Let's see. Okay, here's the brilliant Axel Merner put together a way to really look at this. And what he did is he took all the tide gauges in the United States, he grouped them into parts where the land is uplifting, where the land is going down. You notice there's more of those. And in the center, you can actually tell what the real tide gauge, what the real measure of the sea level is as far as the tide gauges are concerned. The guy's a genius. This is what satellites do. And this is the other measure. This is Topex Poseidon. They fly over the ocean. They look at the ocean topography. And it's very hard for radar, by the way, to reflect off a wave. Why? Because if the You have a high wave and radar hits it, it bounces off and doesn't get reflected. So you have to increase the footprint that you're measuring. And when you do that, usually you have a lot of wave action in low pressure systems, which actually makes the sea level rise. There are all kinds of different changes that can happen. However, the measure is still linear. This is what the Topex-Jason group looks like in space. This is what the University of Colorado puts out as a measure of sea level rise. Again, it's linear. But look carefully at this area right here. Here we have in the late 1990s, and also here you have a tremendous increase in sea level. Let's see if I can get the dates right for this. Yeah, 1998 to 2011, big rise. The fall here, by the way, is due to rainfall falling on Australia. They had tremendous storms, and what it did is it replenished the Australian aquifers and didn't go back into the ocean. So you actually have a little drop in sea level here. Here's the other rise. Those rises are significant. Let's see. Axel Murner said, no, we got to change that chart and flatten it. Why? Because the stations were grounded improperly. There's a paper of his. I'll give you the citation for the paper in the Q&A if you need it. Axel Murner is quite correct, maybe not that severe, but we're going to find out how correct in a minute. This is the problem with the satellites. The satellites aren't that precise. The resolution, the best resolution is 23 millimeters in wavelength. You're trying to measure something 1 and 2 millimeters, and you're using a yardstick that can't measure it. It's like measuring this little box here with this yardstick, and it's quite difficult. And how do you do that? Well, you make 6,000 of these measurements, and you hope sooner or later you get it right. And that's exactly how they measure it with the low resolution they have on the radars. Tracking error is also in the 20 to 40 millimeter range, not good. This is the Europeans' answer, a flying boxcar. It's called NVSat. It has sub-millimeter resolution. This is what it looked like in the lab. NVSat, notice, is different. It actually this is the raw data from NVSat a couple of years ago, about a 0.5 millimeter per year sea level rise, much lower than Topex Poseidon, which is in the 3 millimeter range. Well, how does that happen? What do we do about that? First of all, they adjusted NVSat a little bit. This is how precise it is, by the way. You notice the high points are always in January of each year. There's a 2 millimeter variation each year in sea level rise. This is very, very precise. Now, how come that happens? Well, first of all, we have something that's called the oceans expand when you heat them. Well, the view in January of the southern oceans is basically all water. This is courtesy of Guy Otwell. If you imagine the opposite, the winter view in the south, which is our summer view, you have Asia and North America, lots of land, but not a lot of ocean. So therefore, you have the sea level actually dropping because thermal expansion gets lower. So you have within any given year, you have that 2 millimeter range. But you have a real precise satellite to show you, which is great. This is the original raw data from NVSat. Then they corrected it further. Here is the big problem. This is the sun. This is our solar cycle. This is the sunspot cycle. Remember the years I talked about that were crucial in the satellite imagery. Right around here, we're showing sea level rise. And right here, 2011 to 2014, we're showing sea level rise. Now, why would solar and sunspot activities make the oceans rise? Is it thermal expansion? No, it really isn't. What's happening here is that when you have high sunspot activity, the Earth's atmosphere itself expands into a balloon. People think that these satellites fly in space. They don't. They fly in the upper reaches of the Earth's atmosphere. And it looks something like this. This is Brownian motion. You have to imagine these as being little particles up where the satellites fly. And if you expand the atmosphere, there's more of them. You have a decimal point, 6 or 7 zeros before the first one shows up that will impact the momentum of that satellite. But it does happen. It's called orbital degradation. And orbital degradation will make a satellite think that the sea level is going up. Why? Because the satellite is going down. This is the difference, Envisat and Toprix Poseidon. We had to resolve that difference between 1 and 2.6 millimeters. And the only way to do it is this way. Because the tracking resolution doesn't work, this is called the transit measurement. What we do is we wait 1 year and we track when a satellite crosses that line. If the satellite crosses the line a little bit early, then we know it is in a lower orbit. With an atomic clock, we can be very precise at knowing exactly when. It's an experiment NASA needs to do. The Europeans are thinking about doing it. This is something that you will not see, the world that Al Gore and the IPC want to give you. Sorry, folks. This is the world you deserve. It's the world that Axel Murner, Willie Soon, and our group of scientists here want to leave you with. And I want to thank you very much for the privilege. Now, Hal's going to come up here and talk about CO2 sensitivity.
I want to make it clear, I'm representing a team of scientists that call ourselves the Right Climate Stuff Research Team. We're more than 25 retired scientists and engineers from the Johnson Space Center in Houston. Tom, who lives in Maine, is a member. Bob Bowman here is from Maryland. We have others from around the country who have joined with us. And we also have a few people from the Houston community who are not NASA former employees, but they are very highly credentialed research people from Shell Research and Dow Chemical that were studying this climate thing long before we NASA guys got interested. So I want to make it clear that this is a team effort, and I just happen to be the spokesman today. I want to talk a little bit about how the international climate community talks about how sensitive our climate is to CO2 and other greenhouse gases. The holy grail of climate science is trying to define something they call equilibrium climate sensitivity. And it's loosely defined as the global average temperature rise that will eventually result from doubling CO2 level in the atmosphere. If you read the IPCC reports, it's pretty loosely defined that way. And their more recent AR4 and AR5 reports are incomplete and misleading. The double CO2 level in the climate model solutions is artificially held constant. It's a step function forcing. But in actuality, the ecosystem of the Earth removes half of the CO2 emissions we put into the atmosphere every year, like clockwork. But in an equilibrium climate sensitivity solution, they're arbitrarily holding it constant, which is unrealistic. The other thing they don't tell you is that it takes more than 1,000 years for the climate to equilibrate to this artificial forcing and reach the final equilibrium sensitivity number. Our CO2 regulations are based on what's going to happen in the next 100 to 200 years. So equilibrium climate sensitivity is unrealistic, has nothing to do with our climate for the next 300 years. Yet that's what the EPA is using to regulate CO2 emissions. Things have really gotten out of kilter here. The other metric that climate science uses is called transient climate response, and that's defined as the global warming that would result from increasing atmospheric CO2 levels at a rate of 1% per year until the double CO2 level is reached. This also is very artificial, and it can only be calculated with a climate model. But it's more like the slow rate at which CO2 is rising in our atmosphere. Even now, at a fairly high rate of CO2 emissions, our CO2 levels are climbing only at about half this rate. So even that transient climate response metric is not realistic. So typical of climate science over-reliance on unvalidated models and not enough on data is that neither of the two metrics the IPCC uses, ECS and TCR, neither metric can be verified with physical data. You can't catch them. You can't question them. You have to have a very complex climate model to run and get these numbers. To me, they're totally meaningless. If you can't verify your crucial metric with data, what good is it? So I'm pretty, after looking at this for a couple years, I think I'm going to quit calling them climate scientists until they get a metric that can be verified with physical data. Because scientists look at data, not just models. So I want to talk about the difference in these two dynamic solutions that they get with climate models. I'm sorry. Forgot. I'm going to use this very simple spring mass damper system that most of us have a feel for the dynamics of. And I always like to take a complex dynamic model and have a simple model to think about it with. So in the ECS forcing function at the top, instantly you double CO2 in the atmosphere and you hold it constant forever. Artificially hold it constant. Well, think about what kind of force that is on this dynamic system. It means you're starting with the whole system stable and still with a constant wind force on it, and instantly you double that force. You can see what that spring mass system's going to do. With a light damper, it's going to start oscillating. And eventually, due to damping, it'll damp out and reach a new level. And that's analogous to what that equilibrium climate sensitivity would be. Now, talking to climate scientists, I guess I'll call them scientists today, the damper in their models is fairly large, so it kind of just gradually approaches that doubled ECS value. But let's look at the transient climate response, which is the lower forcing function. Just gradually change that. You can imagine what happens to this dynamic system if you start with it at rest and then gradually increase the force. It's just like taking your finger and gradually pushing it up. It's not going to oscillate. It's going to be in equilibrium all the time. And the mass is just going to gradually rise, which is analogous to a rising temperature. So if you gradually increase the force, this mass is just going to gradually move upwards without oscillating. And that's the way our climate is actually behaving with respect to any CO2 warming that's occurring. So our solution of this dynamic system, in which we're going to use temperature as a measure, the solution needs to look a lot like the forcing function. In fact, this really isn't a dynamics problem, it's a statics problem, and you don't need a big complicated climate model to find out how sensitive you are to CO2. And I will point that out in this presentation.
Are you okay?
I'm sorry, I'm looking at the wrong screen. So what we did to get a verifiable climate, we defined a new climate sensitivity metric that we call transient climate sensitivity. It's kind of like the transient climate response, but we're saying transient climate sensitivity is the rise in global average surface temperature due to the actual gradual rise of greenhouse gases in our atmosphere in the year that the radiative force of the greenhouse gas is doubled with respect to pre-industrial levels. You can verify that because we have data on temperature, we have data on greenhouse gases, and we can find out, and we'll show you how we did it. We can define this TCS value for CO2 only, all greenhouse gases, or any specific greenhouse gas. If you're going to regulate CO2 and you're going to talk about how much damage you're going to avoid by regulating CO2, you need to separate the effect of CO2 from all the other greenhouse gases, because all the other greenhouse gases contribute about 60% of what CO2 does. And when the IPCC talks about ECS, they're usually talking about the effect of all greenhouse gases. So we need a CO2 only transient climate sensitivity value if we're going to talk about the benefits of regulating CO2 emissions. I want to put the double CO2 in perspective. This is where we started from, this very low level. That was CO2 in the atmosphere. This dashed green line is the CO2 level you need in the atmosphere just to get plants to grow. If you don't have that much CO2 in the atmosphere, plants start dying. And we're talking about starting at this very low level, near the critical limit for plant growth, and doubling it. And right now we're about 40% along the way to doubling it from pre-industrial conditions. This is what we allow on the space station for astronauts to breathe, 5,000 parts per minute. I think Walt said on Apollo, we didn't know as much about CO2. His alarm went off at 4,000 parts per million. And this is what you allow on submarines, 8,000 parts per million, and those guys are under the water for 6 months at a time. So in terms of toxicity to humans or any other animals, we're way down here. We're never going to get CO2 levels this high in the atmosphere. You could burn all the fossil fuels on Earth, and you're probably not going to get over 1,000 parts per million. So I want to put this doubling CO2 in perspective. This is the actual rise of CO2 in the atmosphere on a different scale. This comes from ice cores in the Antarctic. The blue part is what's been measured since 1979. And this is our projection for what's going to happen as fossil fuels become scarce. They're going to become more costly. We're going to have to go to alternate fuels. We predict, based on the economic analysis, that we're going to peak out at about 600 parts per million sometime in the next century. I'm going to have to get going here. I'm going to skip over the word charts and just from basic quantum mechanics considerations, if you double CO2 in the atmosphere, we're going to slow down the radiation to outer space, and we will get an equation like this that says the radiative force change in any year is equal to 3.7 watts per meter squared times the logarithm of the CO2 in any year divided by the CO2 level in 1850 divided by 2. So when you get the double value, when this is double this value, this is 1, and we get 3.7 watts per meter radiative force. We're going to force the atmosphere with that. And that gets us to the temperature change should be given by this equation, just based on a linear change in temperature with radiative forcing. So we did a study where we looked at forcing the atmosphere with CO2 or any greenhouse gas. And we also looked at perhaps there were natural phenomena going on. This is the actual temperature data. The Hadcrut-4 data set. And you can see it has a general upward trend, but it's got some oscillatory aspects to it, you know, going up and down that we said, hey, that's not that slow rise in CO2, that's something else going on. And we've, in fact, found a 62-year cycle in the data. This is a 1,000-year cycle that was going on before we started rising CO2 in the atmosphere. So this is how we modeled that Hadcrut-4 data, and we fit it with the CO2 forcing function. The wiggly line here is a 62-year cycle we found in the data, and the dashed red line is the maximum effect that CO2 could be having. Notice it hits the peaks of this red line. The green line, yeah, okay. So this is the way we determined what the transient climate sensitivity was. And there's some more charts here. You can read our paper at our website. And our website was on the opening chart. It's called therightclimatestuff.com. Thank you.
I didn't do that, they did. Well, I have to tell you this, that I'm honored to be here with real climate scientists. And even in the last 18 hours, I've heard so much here that just reaffirms the kind of beliefs that I've come to over the last 15 or 20 years as I've been interested. And while I'm not a climate scientist, I am a student of environmental science. And I consider myself an informed critic. While our home planet is, from orbit, it appears very small and fragile, but humanity has been adapting to continuously changing climate for the last million years. Climate science was a respected field of science up until about 30 years ago, and that's when alarmists began to ignore scientific discipline. Global climate change is a scientific question, and it's dependent on scientific data to understand it. Unfortunately, subjective opinion has been carrying the day. Excuse me. And human-caused global warming has become an issue that's been shaped by opinion, politics, and financial control. Well, I'm not here to make the scientific case against human-caused global warming, anthropogenic warming, AGW, climate change, climate disruption, or whatever the latest phrase is that alarmists are using to just promote their claim that humans are controlling the temperature of the earth. My fellow panelists and many others here already in the last day have disproven these alarmist claims. Their honest science enables me to battle on other fronts and discuss some other things that I believe we should be doing, climate scientists should be doing. Scientists have long known that the sun, the oceans, and variations of the Earth's orbit are the principal drivers of our changing climate. And while we may not fully understand all of the mechanisms or interactions that are involved, after hundreds of years of empirical data, that became an accepted theory of climate change. Well, as you know, scientists have always questioned accepted theories. Back in the 1980s, a small group of individuals became very concerned about the Earth's temperature and what it might do in the future. I hesitate to call them scientists because they abandoned the scientific principles by which their guess about future temperature increases and its cause could achieve scientific acceptance or rejection. Global warming alarmists focused on the small temperature increase since the Industrial Revolution, and they hypothesized that the tiny amount of carbon dioxide that humans were generating was controlling the temperature of our planet. Excuse me. Well, I guess I got to come on one at a time here. Well, okay. Sorry about that. They could have made their case by collecting and making available solid evidence to support their hypothesis. And two, by defending their claims in the court of scientific inquiry, not in the court of public opinion. Instead, they refused to release their data that would permit other scientists to replicate their results, if that was possible. Today's public really doesn't know what to believe about when it comes to humans causing global warming. Politicians, in the absence of knowledge and understanding about climate science, have put themselves out on a limb from which they find it very difficult to retreat. The alarmists have managed to sell the media, the media and the public on human-caused global warming, and something that they've invented called consensus science. Those of us skeptical of those scientists' claims are labeled as climate deniers or fake experts or against climate change. Well, instead of presenting data to prove their hypothesis, the alarmists challenge skeptics like us to disprove that hypothesis. And while scientists are best qualified to deal with the scientific and the academic aspects of that question, all of us will suffer the financial consequences of actions that are taken based on bad science. Today's global warming war is a battle to avoid governmental control of energy consumption and the lowering of our standard of living. The temperature of our planet has been changing for 4.8 billion years. And both temperature and carbon dioxide levels are currently near their historical minimums. The last time they were both simultaneously at such low levels is about 300 million years ago. And about 500 million years ago, the carbon dioxide level was approximately 15 times higher than it is today. Even in the past 10,000 years, there have been many occasions when the temperature was higher than it is today. For the alarmist hypothesis to be accepted by scientific community, one, it must be confirmed by considerable evidence, and two, it must survive all attempts to disprove it. The alarmist hypothesis has not satisfied either of these criteria. Most of today's population is unable to distinguish between science and non-science, or between a hypothesis and a theory. The alarmists, they gained immediate traction with environmentalists, the green movement, the media, and eventually with many politicians. Now, in the absence of supporting data, they are pitching to the public, where politics, media, and money play very important roles. The alarmists like to refer to a correlation between temperature and CO2 levels. Well, we all know that correlation is not causation. But just in case, our friend Dr. Roy Spencer, who you may have heard already, excuse me, he studied the correlation between ocean temperature and UFO sightings. Something I should know a little about. And Roy published a humorous article back in April. Sure enough, the correlation between UFO reports and ocean temperature is frightening. Does that mean that we can lower the Earth's temperature by reducing the number of UFO sightings? Well, the only thing that alarmists are able to cite in support of their simplistic hypotheses, I guess, are the mathematical models which they developed to prove that human-caused carbon dioxide is a dominant factor in controlling the Earth's temperature. Well, these climate models have never successfully predicted anything. And keep in mind, models are based on assumptions. That's opinions. If their bases for, if the bases for these assumptions are wrong, the results can never accurately predict future behavior. And as realists, we should be emphasizing that models are not data. Realists focus on empirical data and the scientific process, neither of which support the hypothesis that alarmists have dreamed up. And that is why alarmists resort to consensus science, politics, money. And along the way, they've convinced most of the media that humans cause global warming. They've convinced them that that is an accepted scientific theory. As realists, we've been fighting on the scientific front, and we are winning the scientific battle. With history, facts, and scientific theory all on the side of global warming skeptics like us, why is climate change still a controversial issue? Well, I think it's because this global warming war is being fought on a number of fronts. There's a scientific front on which we're winning. There's the media front, the public perception front, and the political front, which now also encompasses education. Our challenge is to focus on the public's perception of global warming issues. And the real battle today, and where we appear to be losing, is on the media front. The media plays the most influential role in the public perception, and to some degree with the politicians. We have allowed alarmists to seize the semantic high ground. That's a tactic that has helped move the subject away from the scientific arena and into the political and economic arenas. The media, the public, and most politicians have little scientific literacy, with some rare exceptions, I agree, and they show very little interest in gaining it. And that does not prevent the media from playing a major role in this fight. Many journalists are aggressively pushing human-caused global warming, and they influence a great many readers and listeners. Our challenge at this stage in this war is to engage the alarmists on the media front and bring the media and the public back to reality. Alarmists refuse to accept that today's weather is within historical, natural climate variability, and they are reluctant to admit that man has little control over nature. That is why global warming is sometimes referred to as a religion with the alarmists. To take global warming on faith, you have to reject empirical data and what we have learned about climate change over the centuries, and embrace the unproven hypothesis that humans are responsible for for global temperature changes. These true believers in humans controlling the Earth's temperature cannot be reasoned out of their position. It was not reason that got them there in the first place. It was emotion and politics. Today, the politicization of science is pushing global warming fears in our universities and in K-12 education. For example, the new Common Core framework for science education states that fossil fuels are the cause of catastrophic global warming. Common Core is also saying that man, not nature, has been the main driver of climate change for most of the past century. While scientists are making it increasingly plain that humans have little influence over the Earth's temperature, the alarmists are still winning on the media front, the political front, and the public front, which means we have to do a better job of communicating. Realists need to engage the alarmists on the media front to bring the media and the public back to reality. We should all be telling the media, and the public not to just buy the opinions of others. That includes my opinion. Look at the empirical data themselves. Emphasize that empirical data is not just another opinion. Emphasize that man's historical ability to adapt to temperature changes and how energy consumption has raised our standard of living. Quit letting alarmists control nomenclature. We should emphasize that the argument is not about climate change. It's about the cause of climate change. When writing and speaking, we skeptics should consistently refer to the alarmist claims as human-caused global warming. Don't refer to it as anthropogenic warming, AGW, climate change, or climate disruption. We should make it plain that human-caused global warming is not a scientific theory. It's how the alarmists choose to look at the temperature change in the ongoing human-caused global warming war. This battle for public perception may be more critical than the scientific front. Human-caused global warming may be the biggest scientific myth-based scam in our history. And this fight should not be beneath the dignity of climate science realists, especially when we're dealing with the media. Thank you.
Very good. Thank you, gentlemen. We're getting ready for question and answer. I want to ask one question to Dr. Hal over here. Dr. Hal, I promised everybody you were going to tell them what you thought the maximum temperature rise was going to be by the end of this century. So I'm going to ask you the first question. Do you want to tell them that?
Yeah, when we determined our transient climate sensitivity value, and we put an upper bound on it of 1.8 degrees centigrade, we looked at our projected CO2 rise for the rest of this century and that transient climate sensitivity, and we predict less than 1 degree C rise by 2100. That's all we can see from the data and our projection of how CO2 is going to rise in the atmosphere from burning fossil fuels.
Yeah. Good.